fertilization depends upon having a brain that is intact. So, the first part of the Anisa model in its application is to get the mother and the father in the health. Now, incidentally, there is not very much written about the health of the father. But after all, he does produce 1/2 of the cell. He produces the sperm. And that's a tiny contribution, to be sure. But it's absolutely essential. So, and of course, the development of the baby is far more dependent developmentally on getting the proper nutrition. But Patabi showed me a recent study on the health of males and the quality of sperm. So if you want your baby to be in the best possible condition, you should be providing, if you'll forgive my saying so, first-rate sperm. Now, if you're going to send any of those crippled, worn-out sperm in to do a man's job, that's bad news from the point of view of the baby that's going to result. So we had to get these males shaped up, too. They have to be in good physical shape. We didn't send any of those worn-out sperm. See, there's a big job. You know, those little sperm have to swim what would be the equivalent of swimming the Atlantic for a man in order to arrive at the egg. And furthermore, we think it only takes one sperm, but it doesn't. This is about the relationship of the size between egg and sperm. If we blew it all up, the egg is much, much, much bigger than the sperm. But if I blow up the sperm, it looks something like this. Now, there are some nutrients carried in here which the sperm uses for swimming with. That's the energy the sperm has to have, and it's like you've got enough for a 48-hour trip. You just pack that much lunch. And if he doesn't make it in 48 hours, there's no more grub. That's why the fertile period for the sperm is around 48 to 72 hours. It's the same way for the egg. Now, the egg has got lots of grub. That's why it's so much bigger. Now, this head of the sperm right here secretes a chemical. And that chemical causes a reaction in the corona, which is the outer covering of the egg. And the egg must be surrounded on all sides with sperms poking their noses into it, secreting this enzyme which changes the surface tension and the quality and strength of that corona such that it is possible for one to pierce. But if you send just one sperm, he won't get through. He has to have several million that put the enzyme against the egg, change its coating, and make it possible for one to get through. That's why a male with a low sperm count won't be able to fertilize the egg. There are about 400 million sperms in ejaculation. If sperm count goes down below 200 million, chances are fertilization will not take place. If the man is all worn out and isn't very healthy, he may have a low sperm count. So just on sperm count alone, health is important. But also, the amount and quality of the lunch packed also depends upon the healthy condition of the father. And of course, it's this long, arduous swim to find out the egg. As I was trying to explain it to my little daughter, she couldn't get the sense of how tiny it all is. It's a little bit like having an army of 400,000 people who are hunting for a lost golf ball in the state of Kentucky. That's really what the job is like. And you got 48 hours to do it, and everybody has a little lunch pack. And you see, they don't know where the golf ball is. They just got to cover the whole territory. See? So, you know, that requires some strength. And, of course, you can lose a few on the way, you know. But everybody ought to be well trained to do the job. It turns out that the minute one sperm pierces, there is a change in the electrical charge, the ionic solution on either side of the membrane, on the coating of the egg. And the minute one gets through, all the rest give up. So that you never get two sperms piercing the egg. The minute one makes it, the others give up. Somehow they're not attracted anymore. Yes?
Is it true the female sperm is, say, so-called female sperm is slower than the male sperm? I read that somewhere. I'm not sure if
well,
something like that is true.
Yes.
That's what they say, that they're on.
Well, that's because they're heavier.
They pack more lunch.
No, they didn't pack more lunch, but they're carrying more building material. Because out of 400,000 sperm, 200,000 will carry the gene for female, and the others will carry the gene for male. And the equipment for making a female is a little bit heavier than making a male. And that's why they tend to be a little bit slower, because they're just carrying a heavier pack. I mean, it's minuscule. You can hardly think of it in those terms. And there's also some evidence that the acidity-alkalinity balance in the environment, and you'll see exactly how our theory addresses that, because it says the actualization of potentiality is sustained by interaction with the environment, and it starts right when those sperms are in the environment of the womb or the vaginal passage. The amount of alkalinity or acidity apparently has some influence on which ones get through and which ones survive. And when the egg first comes into the womb, it's more acid, and then near the end it turns to more alkaline, so that if you have intercourse near the end, it will favor the male. If you have it near the beginning, when the egg is out, it favors female. So they're beginning to find ways of actually influencing the environment so that you increase the likelihood of having a male child as opposed to a female child. And that's how these theories are beginning to develop. Now, once this is inside, the egg now has carried enough lunch for both. You know, the egg is taken on a border, you might say. So now lunch has to be shared. And they have enough lunch until they find a place to move in and settle down, which is to find a place somewhere, presumably and more favorably, outside of the fallopian tubes, somewhere in the womb. And the egg then nestles down in some spot in the womb and attaches itself. And that place develops into the placenta. And eventually a long umbilical cord develops. And the baby is encompassed in a sac of fluid. And development then begins with a very careful preparation of the environment in which the baby is born. Now, this miraculous way of going about reproduction is so complex and so extraordinary that you simply cannot help but be awestruck by its magnificence. Billions of years of evolution were required to fashion this system. Life presumably first started somewhere many millions, billions of years ago by the action of sun on slime. And inorganic matter got organized in such a way that they began growing, developing. And developing means taking differentiated parts and pulling them together, and then differentiating that and adding more on, and reorganizing. Every time you add something on, it has to be reorganized. And in essence, that's what development is. We have tried to make our theory of development then rest squarely on the fundamental principles of evolution itself in the universe, thinking that this would then put us absolutely on bedrock. The sac that the baby comes in is filled with a fluid called amniotic fluid, and that fluid is a 9% salt solution, which is the same as seawater, so that the little baby takes with it the same conditions in which life started billions of years ago. It creates a little bit of ocean right inside the mother. And in a very extraordinary way, the baby goes through several billion years of development in the course of 9 months. That is a theory of ontogenetic development repeating phylogenetic development. Phylogeny means the development of the species from the beginning of time and its evolution through various lower forms to man. And I'm not presuming that you believe in the theory of evolution. I'm just presenting to you what it is. If I were in Tennessee, I might be driven out of the classroom by talking about it, because that's what the big Scopes trial was about. But I think a lot of the evidence is in. We used to be different 500 million years ago than we are now. Eileen would be walking around in a cave with a club, right? And she wouldn't look as pretty as she does now, probably. And I might be chasing her with a club. We'd be far less civilized than we are. We wouldn't know the word professional. And in that course of 9 months in the womb, you leap over those billions of years of evolution. That's why at a very early stage of just 3 or 4 or 5 days or even weeks, the embryo of the human infant is indistinguishable from a chick embryo, a pig embryo, a fish embryo, a bird embryo, a cow embryo. They all look very much alike. And we have tails. And we have gill slits. And then there are buds that come out. And if it's going to be a bird, these become wings and these become legs. If it's a fish, these become the front fins and these the back fins. The gill slit moves up and turns into ears. The tail gets shorter and shorter and shorter as the embryo gets bigger and bigger and bigger, until in the case of human beings it just disappears. In the case of the monkey, it gets longer and better. And the arms shoot out and become arms with hands on the end. And the feet shoot out and become legs. But at this early stage, you can't tell what's going to be fish, rabbit, bird, or cow, or human. And to me, that is such striking evidence that somewhere in the dim, distant past, our histories were connected phylogenetically. The question is, what makes one go in one direction and one go in another direction? And that's because inside this sperm and its egg are 24 little chains of tissue called chromosomes. Chrome means yellow. Some means body. They're called chromosomes because they look yellow under a microscope. You think chrome means silver, don't you? Because you got so much chrome on your car. Well, the chrome really means yellowish. And when we say a chromatic color scheme, we mean one that we use chrome to refer to color itself. So they're colored bodies. Some is the same word that we have in somatic. Psychosomatic means mind, psycho means mind or soul, somatic means body. So a psychosomatic disease is a disorder in the body caused by the psycho, caused by the mind, you see. So that's why we have the word chromosome. Now there are 23 of them in the sperm and 23 of them in the egg. And they are made up of chains of little chemical packets called genes. And these genes are made up of complex protein macromolecules called DNA, deoxyribonucleic acid. That complex molecule contains the blueprint that says how to use what materials coming from a mother's blood to build up the new baby. So the mother's blood comes by and all this material is thrown off into the placenta. It's then carried through the umbilical cord down to the construction site and dumped. And these cells take it on. Separate pathways, which are the beginning circulatory system, is built out of the same materials. So you have to build the pathways out of the same materials, and those pathways ultimately become the circulatory system. And incidentally, just when the embryo is just tiny, like, I mean, just kind of an amorphous blob, the channel, the main vein is there, and very early it begins pulsating. And eventually a heart grows there, and the whole circulatory system is connected. Well, all these supplies from the mother's blood is distributed to various construction sites. Every cell is a construction site, and every cell has a delivery system to it. The building materials are dumped off, plus oxygen, because it takes energy to do the building. So they not only are building, but they are using up energy to do the building. So there are patterned uses of energy in the construction of the biological creature itself. So the potentiality, biological potentiality is right there. Every cell gets some things dumped to it. You see, all the material comes by like a big smorgasbord. And this cell says, well, I don't need that, but I need this. I don't need this, but I need that. And each cell knows what it needs. And the recipe, you might say, for what it needs, the construction plan is in those genes. And it takes what it needs and it puts it together in the way it has to be put together. And in 9 months, 9 short months, a new human being is created. Now, there are 2 propositions here in the theory of development. I'm going to come back to nutrition in a moment, but I must introduce 2 general propositions here. One I've already talked about. One is that this translation is sustained by interaction with the environment. Keeping in mind that all interactions aren't the best, nor are all environments the best. There's variation in qualities. And we can manipulate interactions and we can manipulate environments. And they will make a difference on what comes out. Secondly, both processes of development depend upon these general notions of differentiation and integration. In the case of psychological potentialities, generalization is added. And these are true in the biological area just like they are true down here. after about 128 or 356 cell divisions, the cells stop replicating each other exactly alike. They differentiate into three main kinds of tissue. One is called an entoderm, one is called a mesoderm, and one is called an pardon? Exoderm. Is it? Mesoderm, entoderm, ectoderm. Ectoderm. Derm means skin or layer. And one of those becomes skin, fingernails, hair, bone. One becomes the internal viscera and the blood system. The other becomes the nervous system. Then, once those get differentiated, each of those begin differentiating. But as it is differentiated, it has to be integrated, otherwise it won't function. So there is the most complex, magnificent drama of differentiation and integration going on out of these building materials that the mother's blood brings to the child. Now, I think it's pretty easy for you to imagine that if the supply train comes down and things are missing, that the builders down there, all in the dark too, you know, they're doing this without any light, 24 hours a day. They have to select what they need, and it always amazes me, they have to do it in the dark. And if it's not there, what do? Well, they don't go on strike, you know, because there's a set timetable. I tell you, it just goes on. Now, the time can be slightly variable, but not much. Because 9 months is going to be it. That's the contract day. Thereabouts. Therefore, if there are lacking nutrients, the quality of the project is impaired. And the final product is of lower quality. Just like it is if you're building a building and you can't get the right cement, or you can't get the marble, or you can't get whatever else you need. You have to use cheaper materials, you have to cut back, you have to make do, and you have an inferior quality when you come out. Now, the thrust of the baby is such that, and the development of the child is such that, if the mother isn't eating something that is needed, many times the baby will rob from the mother's own tissue. In other words, it is possible for the mother's body to decalcify or to take off some calcium from her own teeth and bones and put it into the bloodstream and give it to the baby if she's not eating enough food that has calcium. That's why if a mother has one baby after another, bing, 13 in a row, and she's not on a good diet, you will see a deterioration in her. Her teeth may suddenly just go to pieces and get lots of cavities, and so on. See? So, not everything necessarily comes directly from what the mother eats, because it's connected with her bloodstream. Some other things may be robbed from the mother itself in order to keep the job going. Now, I want to introduce another theoretical proposition called critical and sensitive periods at this point. A critical period is a time during which there is rapid development of a given tissue, or in the case of psychological potentialities, there is a rapid development of learning in some area. And during that time, if the organism doesn't get the nutrients it needs or the experience that it needs, then development may be irreversibly damaged. Example. At about 3 months, maybe it's 3 weeks. You tell me which it is. I can't remember. I think it's 3 months. At about 3 months, the eye is forming in the embryo. And the retina of the eye requires large amounts of vitamin A because the mechanism that enables us to be sensitive to light is a chemical called visual purple, or rhodopsin. The main chemical constituent of which is vitamin A. If the mother, and so at that moment, you gotta have vitamin A, and if you don't get vitamin A, you'll be blind. So that's a critical period. If a mother gets German measles at 3 months, German measles is known to destroy or use up large amounts of vitamin A. So since the mother has such a big claim on the vitamin A to just handle the disease, the baby doesn't get any. Those babies are born blind. In other words, when it came time for the blueprint to build the eye, the material that came by didn't have any vitamin A, and therefore they built it without the vitamin A, and therefore it won't work. It's a little bit like the car going down in the Ford plant, and when it came to you, you are supposed to put in the spark plugs, and there's none on the conveyor belt, and therefore you put everything else but the spark plug in, and the car goes right on by, and when it gets to the other end, it will not work because it doesn't have spark plugs. And it wasn't your fault, it's just the fault of whoever it was who was organizing the conveyor belt. Now, you can imagine how many of those kinds of things could go wrong. And there are lots of them. Certain kinds of emotional stress, for instance, are known to require certain chemicals or certain vitamins or certain nutrients. If at the time, you see at one point this baby looks like this. There's a big sort of eye cavity, and the gill slits are here, and the arm buds are here. This lip is split, and at some point it seals, and it makes that little mark there that we all have. What is that called? Anybody know? I can't think. I want to say the frenum, but the frenum is what's underneath right there that connects it to the top of the gum. I can't think what it is. I think it's because my wife's mother, my wife told my children that they got that little mark because they cried one night and an angel came down and said, shh. And it's not a terribly scientific explanation. And so it made a little, the clay was just being molded, and so it just made a little mark at it. That's not really the way it happens, however. But we have that split. And if that doesn't seal, we say the person has a hair lip because in rabbits it never does seal, you see. See? Go try it out. So it's not a hair lip. That's a mustache. This is something else. Now that same sealing, there's a split all the way back to the palate. That's why hair lip and cleft palate are often associated. Now it's known that there's just a few hours when that is being, there's a 48, 72 hour period when that's being sealed. If the mother undergoes great emotional stress at that point, it could fail to seal, and the child could be born with hair lip and cleft palate. Some of these things may be genetically determined. The defect may be in the actual blueprint, or it may be that the blueprint's okay, but the cells didn't have the materials when they came down. See? Now, certain kinds of drugs foul up the capacity of the cells to follow the blueprint, like thalidomide. Thalidomide was a tranquilizer taken by mothers in Germany mostly, and it went across the placenta, and in a sense it made the cells drunk who were doing the building, and therefore they couldn't follow the blueprint, and these babies were deformed. They had no arms, they had no legs, and in every case these drugs had an effect at a given time, usually at the time of budding of the arms and legs. So these children are born. In fact, just last week I saw 2 children, fraternal twins, thalidomide twins, and one of them's legs seemed to be okay. The other one leg is about a foot shorter than the other. They're both about 6 or 7, but their hands come almost directly out of the arm, out of the shoulder, so that they looked really like flippers, and yet they were bright boys and were somehow adjusting rather miraculously. Because this little boy came up to me and said, "Are you Mr. Jordan?" I said, "Yes." And he put his hand to me to shake, which was right out of his shoulder. Now, there's an example of how the whole thing couldn't get put together right during a critical period. And I suspect they were thalidomide babies. I don't know. He looked like it to me. Of course, you know, the thalidomide company has nearly gone broke because they've had just billions of dollars of suits against it for the thalidomide babies. Well, I don't think there's any way that we can stress the need for proper nutrition. Just isn't any way. Now, one other point, and that has to do with the amount and quality of oxygen that the mother takes in. A brain cell, once they start, a brain cell cannot live for more than 5 seconds without oxygen. And it cannot survive without sugar, glucose. The brain lives entirely on sugar and oxygen for all intents and purposes. Now, it doesn't mean you should go, if you go drink some sugar water, you'll have a pickup, all right, but you also get a shot of insulin to metabolize it, and it may overdo it, and then you have a downswing. But it's important for a mother to be breathing properly. And if she is a smoking mother, and she is clogging up the lungs with tar, which is designed to, I know you just lit up a cigarette, I don't mean to be embarrassing you, but I don't think you're going to be pregnant in the near future, so I'm going to go on.
You can't afford another one.
Of course, if he had another one, I bet he could make a lot of money. If he had it. In fact, I'd volunteer to become his agent. We can make $1 million together. But if the lungs cannot take the oxygen and get it down to the baby, then of course you may be impairing the development of the cells. This is also why it's very important when the baby is born for the physician to milk the umbilical cord. The baby should actually be held lower than the mother, not higher like they often do. It's just dumb. They should hold the baby lower than the mother, and they should milk the umbilical cord and get all of the blood and the oxygen down into the baby and get the baby breathing before the umbilical cord is cut. There are lots of children that suffer from anoxia, a lack of oxygen, and brain cells are destroyed in 5 seconds. That's all it takes. Now, of course, there's blood circulating through the brain, and if that blood has oxygen in it, you don't have any trouble. But if the blood is deprived of oxygen because there isn't any coming from the mother and the baby hasn't started breathing yet, or there are complications, the baby's got the umbilical cord around its neck, and therefore when it comes out, the cord is tightened, and therefore these arteries which carry oxygen to the brain are squished, then the child could be born mentally retarded simply because too many of the brain cells are killed because they were deprived of oxygen. There are so many billions of things that can go wrong. It is an absolute miracle that we made it. Really it is. But then, of course, there have been so many billions of years to iron out the bugs in the system. So, there's that way of looking at it too. Now, after the baby is born, nutrition is still very important because in the immediate postnatal years, these 14.5 billion cerebral neurons have got to get insulated. They're like sort of raw wires in electrical circuits. And they are carrying electrical impulses. And they'll just go from one wire to the next wire unless they're insulated. So one of the first big biological developmental tasks after birth is to get all those wires coated. And it's coated with a fatty tissue called the myelin sheath. There are two important implications for nutrition here. You've got to have the intake for that myelin. And incidentally, if it doesn't get myelinated, you'll be mentally retarded. And one of the important chemical necessities for completing the myelination is thyroid. Thyroxine is the hormone produced by the thyroid, and the critical feature in thyroid is iodine. And if you don't have iodine in your diet, then you may not be providing enough thyroid, in which case you can be mentally retarded because of it. Now, the thyroid is right here, and if you are not having enough iodine in your diet, the thyroid will try to do its job by just getting bigger. And you will form a protrusion of the thyroid called a goiter. And that will put pressure on you, and it may cause your eyes to bulge out. So you've seen people with goiter. Now, it used to be that a lot of people around the Great Lakes always had goiter. And that's because the lakes drained iodine from the soil so that the vegetables that grew around there didn't have any iodine in them. And therefore these people just would get thyroid problems, goiter. It was then that the law was passed for iodizing salt. And it got rid of goiter practically in this country. So that when you go to buy salt, you'll see some of it says iodized and some of it doesn't. But just to be on the safe side, you ought to get iodized salt because it means that there's a little bit of iodine in there, which is good for your thyroid. A child who is born with thyroid deficiency, and either didn't get it from the mother or there wasn't enough to get it going, will be called a cretin. And this child, if he is not given thyroid and iodine, will be definitely mentally retarded. He'll grow up to be an adult with a mental age of about 5. And I have worked with such children and seen them. And you got to get them within the first 9 months after birth. Otherwise it's too late. And they miss the critical period. I had a friend in the Army who had such a baby. The baby was misdiagnosed and on the wrong medication for 10 months. And when we finally took the child to another physician, it was diagnosed as cretinism and put on the right diet and began growing normally. But the child never went beyond mental age of 5. He's now 24 years old, and he works as a stock boy in a grocery store. He's very grown up and mature. He's big. He's 6'2", but he can't handle anything beyond that. But I tell you, his mother did a magnificent job with him because he's a very responsible, loving person. But he could never go beyond about. So he grew up emotionally to be a mature person, but cognitively he can't handle anything more than about, he's still at the concrete operational stage as far as Piaget is concerned from a cognitive point of view. There's one other point that nutrition is important for, and that is with inadequate nutritional intake, the quality and extent of integration among the nerve cells is reduced. A nerve cell looks something like this. I should have had Patavi's slides for you. Patavi has made some magnificent colored slides of nerve cells blown up thousands and thousands and thousands of times, so they just look like cables, telephone cables in a way. But these cells have branchings out here. Here's the nucleus of the cell. If that dies, the whole cell goes and it never comes back again. If you have inadequate nutritional intake, you don't get very many of these branchings. And these branchings have to connect with other cells. Your intelligence anatomically rests on the number and quality of those branchings and their interconnections. If you are on a low protein diet after you are born, and you see you don't get any more number of cells after you're born, but the amount of branching continues. And if you have inadequate protein intake and inadequate thyroid, this branching will be reduced. And of course you won't get as much myelin sheath insulation on it. And of course things get shorted out then if you don't have the myelin sheath. So nutrition is absolutely critical. Now tomorrow, or this afternoon, I'm going to talk with you a little bit about some spurt periods in growth, because these spurts are like critical periods, and there's some new work being carried on in Brandeis University by Professor Epstein, and he's developed a new notion called phrenoblysis, special brain and mind growth periods, which may have some implications for us, because we know from our own work that development goes in spurts. It has a kind of rhythm, and if you can be in touch with the rhythm, you can, in a sense, dance with the music. And if you don't know what the rhythm is, then you're kind of out of touch with the reality of the child, because reality adheres to the process, see, of his becoming. So this afternoon I want to just wind up the nutrition thing. Let me just make a couple of points here, namely that nutrition has an influence on how well you can pay attention. And there is no actualization of psychological potentialities through learning if you can't pay attention. Paying attention is in part learned, but it's rarely taught in schools, on the one hand. On the other hand, it has a nutritional foundation. If you have inadequate vitamin D intake, for instance, it's hard to pay attention. And just like instruction has to be individualized to serve the growing organism, so do diets. So that when you look on the jar and it says the United States government established minimum daily requirements, may not be yours at all. That's just an average. Some people need far more vitamin C than others. Some people need far more vitamin B than others. Some need far less. So we have to learn how to individualize intake from a nutritional point of view, just like we're individualizing instruction. And we have some, I mean, there's always a kind of a general average where you can make your best guess. But after you get that, then you must learn how to deviate in one way for another. And Patavi told me of the experiences he's had where a woman just was having a terrible time, and they gave her mega vitamin therapy, and she got well right away. And the minute they took her off, she got sick again. And they finally learned that this woman just has a certain kind of metabolic profile, and she requires normally much greater amounts of intake of certain vitamins than other people. And other people just need less, you see. So we're learning more and more about the relationship between nutrition and later growth and development. And ultimately in NISA schools and staffs there will be nutritional experts who not only keep a profile on the nutritional status of children, but the staff as well. Because you cannot be a good model and therefore a good teacher if you are not in the peak of physical health yourself. Because you just can't model that vitality and interest in life and learning if you're worn out, fatigued, and ill. And you know how to drag it is to try to work with children who are demanding if you're not feeling well. It really is difficult to work with children if you're feeling down and out. And any mother will tell you that, and any teacher knows that too. Okay, any questions now? Yes?
Just before we leave the nerves, how long does the myelinization of the sheep take?
Well,
is that complete within the first year, or is it?
No, it takes somewhere around the first 2.5 years, but most of it gets done. I'd say the bulk of it gets done in the first 8 months postnatally. But you see, this branching continues on slowly, and then it has to be, every time we get a new branching, it has to be insulated too.
How long will the branching occur before it stops? Is there any way we know it?
Yes, in a general way, and I'm not sure what the precise time is, but I can find out for you if you want to know. It's just that I don't happen to remember it. But the way we know is that various children have been killed and autopsies performed, and we know how long they have, how old they are, and therefore when their brains are analyzed we can tell what the extent of myelinization is and whether or not branching is still going on. And that's how we know. The same is true for animals though, although a lot of animals don't have a cortex. See, a rat's brain is, well, a rat has a cortex, but it's not convoluted like ours. And, well, I won't talk about convolutions now. That's something else again. I'll talk about that when we come back from lunch. Anything else? Okay, have a good lunch. And rather than starting Mr. Epstein on phrenoblysis, which is a marvelous word.
Would you smell it?
Yes.
Yes, probably.
Phreno in Greek means mind or head, skull. You know the ancient phrenologists, you know what phrenology is? Phrenology is a pseudoscience whereby you examine the bumps on the skull to predict one's future or to analyze one's personality. Blysis is the Greek word that means a welling up or swelling up of matter. So, phrenoblysis means a swelled head. Well, not... He uses it to refer to periods of spurts in growth of the brain, which is reflected in an accelerated increase in the size of the skull. Because the baby is born with a finite number of brain cells, the skull, the brain does not increase in size by adding new cerebral neurons. It may increase in size by adding other kinds of cells, like supporting cells, the glial cells, that are surrounding each of the neurons. But of course, when you myelinate all these cells, add the sheath, and the branchings go out, of course, when you have 14.5 billion of them, each getting more branches and getting myelination, and some of those other cells might be added, it increases in size. Yes?
What is the life expectancy expectancy of a brain cell? The length of life of the individual?
Yes, yes.
Have they made it something distinctly different than other cells?
Well, nerve cells are different, yes, because they have the capacity to store an electrical charge and fire it. And no other cells do that. And it's a very complicated operation because the brain cells, or nerve cells generally, are of different lengths. The way the impulse travels through the cell is different. And well, I'm not sure how much we want to get into that now. Let me just make one perhaps point, and that is that when you have one cell connecting with another, say that the impulse comes down here, it will go through all of these roots, and then it'll connect with another cell and goes on like that. The impulse is not purely an electrical one. So nerve impulses do not travel at the speed of electricity. They travel much more slowly. The nerve cell comes in layers inside each other like this. And on the outside, you'll have positive ions, and on the inside you will have negative ones, say. And right there, there'll be a negative one, and then positive and negative here. And this reversal of positive and negative charge rolls down the nerve, just like a wave. In other words, this positive charge goes right down the wave with the negative one right underneath it. And that is mediated through the ions, positive and negatively charged ions. So it's a chemical electrical impulse. And when it comes down to the end right here, I'm going to blow that up now. This area right in here is called the synapse. When that nerve impulse comes down here, it causes a little chemical, a chemical called acetylcholine, to be released. Just a teeny drop of it. And that creates a change in the electrochemical context, the kind of a field force there. And if it's strong enough, it sets up the impulse here, and it goes up the next one. Many, many times it's not strong enough, and therefore it isn't carried on, it's stopped. The body is made up of thousands of these connections, billions of these connections. And lots of these impulses are never carried on beyond certain synapses. In fact, there's every evidence that volitionally we can even inhibit the impulse going beyond the synapse. The big mystery in life is how we ourselves decide volitionally to initiate the impulse first of all. You talk about efficient causes and the miracle. I can initiate myself out of conscious intention nerve impulses to go in a variety of ways so that my tongue and my lungs and my vocal cords can create a set of words to create a meaning. And I have to initiate every one of those impulses that go through thousands of nerves in a split second in order to come out with what I'm talking about. Not only does it do that, but the sound has to go in my ear, and I check what I'm saying to make certain that what came out was what I intended to come out, because if I hear something come out that I didn't intend, I have to correct it. So I have to listen to what I'm saying as I am saying it, while at the same time thinking of what I'm going to say next. Now, if you don't think that isn't a trick and a half. To keep all these going billions of times per just billions of these firings. You see, each neuron in the brain stores up an electrical charge and discharges it 15 to 20 times a second. You see how quick a second goes by? 15 times between each one of those. It stores up a charge and fires it. So that when you have the majority, say 85% of 14.5 billion cells storing a charge and discharging it, if they all, say 85% fire at the same time, it creates a big enough change in the electrical field force that you can pick it up when you put an electrode against the scalp. And that's how you measure brain waves. That's what the brain waves are. So the complication of the synapse is very important, and we think that what we call intelligence and learning competence rests initially on having a large number of these connections available for consolidating pattern firings. And presumably when you learn something, the impulse takes a certain route. And when you remember it, it takes the same route. But there are just billions and billions and billions and billions of possibilities of routes. That's why it seems as if there is no end to the things you can remember. But we are not quite certain how the body decides how it can remember to remember, how it manages to retain that specific pattern so that it can repeat it at will. These are some of the things that I'll be discussing with you a little bit more when we have the memory seminar next week. There are chemicals that can be injected at this site so that the impulse isn't transferred. When you take an anesthetic, it works on the pain fibers. See, some nerve cells carry the message of pain, and they aren't really used to do too much else. And these are usually long fibers. In fact, some of them may be 2 or 3 feet long. You know, they might be down in your foot and go right up to the spine. Might have one nerve that long. Because it takes time to jump the synapse. And if you're giving a pain message, it's usually an emergency message, and therefore you don't want any delays. So the pain fibers are usually called C fibers. They're long, and the nerve impulse travels quickly. Other kinds of fibers take other kinds of messages where it's not so urgent. They're shorter, and you have to go through a lot of clearinghouses. Each time you hit a synapse, you've got to go through a clearinghouse. When you take drugs like smoked pot, or you take LSD, or any of those psychedelic drugs, they have an influence on the synapse. And this is what provides all new kinds of experiences for you. And a lot of those are visual, and you project them back out into the world even though there's nothing out there. In fact, that's precisely how hallucination works. The nerve is stimulated to fire, but it's not stimulated by the sense organ. So that the optical nerve is stimulated by these drugs to send messages back to the occipital lobe, which is right back here, which is where you interpret the experience subjectively of vision. And naturally, the mind has learned to project back out in there. So you will believe that what you experience back here is, in fact, out there. And that's why a hallucination is such a difficult thing to deal with. And if you have added to visual hallucination, tactile hallucination, and auditory hallucination at the same time, then you can hallucinate a big bear coming in the door, and you can smell him, and you can pet him, and you can hear him, as well as see him, and that will convince you that he's there. When I was working in the mental hospital, we had a woman who was in a padded cell. And you put a person in a padded cell because they're suicidal, and or just so psychotic that they're reckless with their body, and so they get a run and mash themselves against the wall. So you have to make a small room so they can't get much of a run, and then you put pads up and down and around so that if they throw themselves up and around and down, they can't really break anything. You just get a headache. And I remember one woman who was active hallucinator, and she hallucinated through all the senses, olfactory hallucinations and visual and auditory and so on. And I remember once she called me in, And we had a sheet on the floor for her to sleep on, and she had torn the sheet up into strips about this wide. And she had rolled them all up so that they were little white rolls about this big. She had 6 or 7 of them. And then what was left of the sheet, she just was about this piece this big. She had it down, and she had these rolls right along here. And she now could turn that basic visual form into a sow with piglets. And she hallucinated that she was in the barn, attending a sow, having pigs. So when I came in to give her some refreshment, some food or something, she immediately said, "Oh, come over here." She said, "This sow, help me move this sow. This sow is about ready to roll over and squish the piglets." And she'd been a woman with farm experience, and if anybody who's had a farm experience, you know that when a sow has piglets, sometimes she's a little bit rough, and she kind of rolls over, and if a piggy is in the way, he gets squished. And so she said, help me get this sow. She was, so, and I put down the tray, and I was right over there in a minute. She was so, before you know it, you can be driven crazy yourself. And so we finally got the sow moved off the piglets. And I'm sitting there feeling rather sheepish and funny, lest anybody's watching. And so finally I decided I have to call an end to this charade, you see, because she's putting such pressure on me to participate in an hallucination that I feel if I go on with it another 5 minutes, I'll be hallucinating myself. So I take the sheet that they're sort of on and just flip it like that, and all the little piglets go all over the place. And she immediately, all that fades. She sits in a chair and she says, "Let's you and I get together and buy the University of Chicago." I mean, she just completely left the farm scene. Shortly, she was back at the farm scene, and the farm caught on fire. She was going, and she said, open up the window, call the fire department. There's smoke in here, the hay's on fire, and so on. And you can tell by the way her eyes are puffing up and everything, that the tears are coming out, the smoke is burning her eyes and everything. Now what's happened to that woman is these nerves are being stimulated inside, and they are terminating in the place and being interpreted by those cells there in some way, shape, or form. Now, every night you go to sleep, you dream 6 to 8 times. You just don't remember it. But we have absolute scientific proof now that you do. The only reason that you wouldn't would be if you were on drugs, because it upset the dream cycle. And in fact, this is now thought to be one of the ways in which drugs are harmful. But ordinarily you dream 5 to 8 times a night. And during those dreams, you are hallucinating, but those are normal hallucinations. And it's such a cheap way to travel widely and to have all kinds of marvelous experiences, some not so socially acceptable, and it doesn't cost you a penny, and nobody will take you to court. I mean, it's just it's the most marvelous thing going, really. And you can remember them. I mean, you can just learn marvelous things in your dreams because you can pick up experiences you'd never have otherwise with your dreams. And I wish we had time to talk about dreaming, because that experience and cats who were prevented from having dreams 5 nights in a row just died with no organic difficulty that they could find. So I don't know whether a man would die if you didn't let him ever dream. And the way you do it, you can hook them up so that the brainwave pattern changes during dreaming, so you can always tell absolutely when the dreaming starts. And therefore, the minute it starts, you just wake the guy up. Now he has to start all over again. Maybe take 40 minutes before he gets to the dream cycle. And just when he gets there, wake him up again. So he has an interrupted night because he gets wakened up 5 or 6 times, but he doesn't get to dream. And the control groups that they used, they woke the people up after they had dreamed. And those people didn't mind going on with the experiments. But those who were deprived of their dreams simply wouldn't do it. They simply left the project. Well, that was called a creative digression. from phrenoblysis, back to which we are now. We have now arrived, yes?
I think I've got 7 hours of digression on here.
But I'll tell you something about my digressions. They're always substantial. By that I mean, it's important information. It just may not have a direct bearing on the point.
Well, it's very, because I was thinking, now I'm going to have to edit these things. Then I'm saying, well, no, I can't edit this out because it's really building up.
Well, I always connect it to what I'm coming back to, so it makes editing difficult, but you could edit it anyway. Epstein noticed in the literature people reporting accelerated periods of increase in skull size, and therefore came to believe that this is probably because what's inside the skull is getting bigger faster. And sure enough, that seems to be the case. That when the inside of the brain increases in size, then there is an accommodation by an increase in skull size. And he wanted to find out when these spurts were. And without giving you all the data, he found that spurts were between 2 to 4, 6 to 8, 10 to 12, and 14 to 15. And that 3, 7, 11, and 15 were more or less, you could say, peak periods of the phrenoblistic period. Now his question was, should the child have a different experience at this time? Because you could treat them as critical periods. The critical period being a period during which there are accelerated periods of growth, during which time modifiers have maximum effect. Now supposing you can have a benevolent modifier during these periods, could you get more educational mileage out of those times if you knew precisely what the periods were? He thinks yes. This work is very new. This is a 1974 article. He came up to our nutrition conference and spoke to us. We'll be in touch with him to get more information as we proceed with this. The implications it has for Anisa, which remain totally unexplored and which is very premature for me saying, but let me say it anyway, is that these seem to be periods where there are new integrations of these cells. And that we would have content curriculum emphasized here, where there is more or less rote memory of information, and process curriculum emphasized there, when you're talking about pattern use of energy in the head for accomplishing new processes, which we'll be talking about later. So that you would sort of go from content to process to content to process, just in terms of emphasis. That would be one possible implication of that for Anisa. Totally premature for me to say that, I feel certain. But I just want to give you an idea of kinds of possibilities and how the model itself can accommodate any new thing that comes on the scene because of its ultimate ontological principles, which are as broad as you can get and as deep as you can get, and therefore anything that happens will be able to be accommodated by it. Something may happen tomorrow that wouldn't accommodate it, but then we'd get busy and reconfigure the whole thing so it would.
Next time he comes around, ask him how you could accommodate individual differences. There would be such a wide variation that each one of those things would be running into the other one for each group of children.
This is the funny thing. This is the thing that kind of worries me about his work, is that he says these swelling periods are pretty age constant. Now we know that there are some things that are age constant. For instance, the time of the formation of the eye in the uterus, in the womb, It's just the 3 months. So that sometimes the biological maturational timetable is pretty well fixed. He could be right.
Well, yeah, but teeth, like their youngster losing their teeth at certain points,
Yeah.
but there's still a range.
There is.
As a classroom teacher, you're always dealing with the fact that child A is here and child B is there.
I know.
I mean, the whole thing we're teaching, it seems to me, is like get off the chronological stuff and get on to the
That's right.
developmental stuff.
Well, that's precise. I mean, you put your finger on the thing, which is worrisome, but he's pretty.
You need a
Here's,
thermometer that you can just.
that's right. Wouldn't it be nice? Anyway, we'll see. I'm sure that this idea is going to be modified with additional experience and data. And the problem, of course, is you have to go around and collect dead babies. And in order to cut open their skulls and examine them. And you've got to have them at different ages. And if you're going to look at to see what's happening internally, the thing that he did was simply to measure around the head. And when you get lots and lots of cases together, then pretty soon a pattern begins to emerge. But it's going to take some time before we get all that information ironed out. My only point here was that the model stresses the interconnectedness between biological phenomena and psychological phenomena, and therefore it would be no surprise to us if we were able to show that at the time there is an increase in the size of the brain, we would see something happening in learning in the actualization of psychological potentialities. Yes?
I was wondering, does that stop at 15?
Pretty much.
Is that what
Yeah.
I was wondering if
Your,
it continued on.
your head doesn't swell anymore after 15 or 16, except psychologically. I suppose you can get a fat head at any point in life, but that usually means something else other than just size. And incidentally, there is no absolute correlation between size of brain and IQ. Except perhaps in the given individual case, so that a child whose head is bigger now, he's got a higher IQ than he may have had earlier. But if, after all, Sir Walter Scott, you know, was a very famous microcephalic. Cephalic is another Greek word meaning head. Micro meaning small. If you've ever seen pictures of Sir Walter Scott, he looks deformed because his head is so tiny. Looks like a little baby's head sitting on a man's shoulders. And he was a very intelligent man. You may not like his poetry, but he was regarded as a literary figure of some merit. Yes?
Yeah, at the present time, is the model recognizing anything in the area of critical periods for learning?
Well, in language development primarily. Because we know there are two speech areas. On the left cerebral hemisphere, you know, the brain is divided into two halves. Here's the man's nose, here's his eyes. On the left cerebral hemisphere, here and there, are two areas which determine the acquisition of language. And the critical period for the consolidation and development of that part of the brain begins around 8 months and goes to 2 years. That's the first critical period. Then it extends to 8 years, and then on up to puberty. The best time to acquire a new language is between 8 months and 2 years. The next best time is between 2 years and 8 years. The next best time is between 8 years and 14. The worst time is after 14, which is when we introduced it in schools. Now this is one of those instances where the school system is organized absolutely in the wrong direction, flying in the face of everything we know about growth and development. Patabi Raman's wife is French. Patabi is an Indian, East Indian, whose language is Tamil, which is one of the ancient Dravidian languages, one of the oldest languages on the earth. And he has a little daughter named Shakuntala, which means nightingale. And he just had a baby son a few weeks ago. Yes. What, just 2 or 3 weeks ago?
2 dozen.
And the baby's name is Vivek Kalyan Raman. Isn't that nice? Musical. But anyway, little Vivek is busy crying now, and Shakuntala is busy trying to organize the whole thing. She's only 3. But Shaku, we call her for short, Shakuntala, Shaku. Shaku is trilingual at the age of 3. She understands French, Tamil, and English. And believe me, those are different languages.
She can translate for you. When I don't understand, she translates for me.
So, and Patabi can demonstrate. He'll say in Tamil, Shaku, go close the door. And Michelle can say in French, Shaku, open the door. And then I can say in English, close the door again, Shaku. She'll close it. She understands all 3. And, well, she's not 3 yet.
She'll be 3.
She'll be 3 in November.
September.
In September. So she's 2.5. But she's got the basics of 3 languages down. And Tamil is really a very different language. I mean, it sounds like so much sputtering to us, wouldn't you say?
Isn't it harder, excuse me, isn't it harder to learn, it's a lot harder to speak the languages, to actually verbalize them?
Oh yes, reception always
It takes
occurs
longer,
before
right.
production.
And then for a child to speak normally.
And a
say
child,
it too, right?
yes, and a child who is exposed to 2 or 3 linguistic systems simultaneously will learn to talk later than a child exposed to just one. After all, there's an awful lot to get coordinated and sorted out. And interesting thing is though, her preferred language is English, in spite of the fact that it's not the native tongue of either her father or her mother. But you see, Patabi doesn't speak French fluently, and Michelle doesn't speak Tamil fluently, so they both speak broken English. Well, not broken English, they both speak English perfectly well, but it's each with 2 different kinds of accent. And very funny. I mean, it's to hear them both talk. It's Patabi speaks in an Indian English accent, and Michelle speaks it with a French Canadian accent, and Shaku speaks with just kind of an Amherst New England accent. So it's amazing how they make the difference. And somehow she senses that the most parsimonious effort for her linguistically is to speak the one language that they both understand. So she understands both, but she speaks mostly English. If she does go to another language, it's usually French, because Michelle is around more than Patabi, I feel sure. And so I hear her saying, I want some juice. She says, jus, instead of juice. Or, well, she says, I mean, she can say all the French words that she hears, but she doesn't very much usually. Well, the reason she could master those 3 languages by 2.5 is because that was the critical period. Now, if you had waited until she was 14 and tried to give her lessons in French and Tamil, not only would you have terrible fuss on your hands, but it is doubtful that she could have ever assimilated those other 2 languages without accent. We also know that if you get clobbered on the left side of supposing you get axed on the left side of the head when you're 8 months, what happens? The speech functions are transferred immediately to this side, and they begin developing here. The onset of language production will be delayed, but not impaired ultimately. On the other hand, if after the age of 8 you are axed here, there is permanent speech damage done. It does not get transferred to the other side because you've missed the critical period and the other side is doing something else now.
Is it on the left side for left-handed people?
Yep, on the left side for everybody.
What about the children who stutter or have language problems?
Well, there are a lot of theories about stuttering, and I'm not sure we want to go into them now, but there is the thesis that since the language center is on the left side, it favors right-handed people. If you are left-handed, it means the right cerebral hemisphere is dominant, because at the base of the skull, all these nerve bundles come over and cross. So there's a crossing at the base of the skull. That's why right and left hands are organized by left cerebral hemisphere, and left hand and left leg are organized by right cerebral hemisphere. Therefore, if you're left-handed, it means there's right cerebral dominance, but it means the speech center is on the left-hand side. So that's why they say that left-handed children may have speech reading difficulties. However, all the evidence on that is so confusing that I wouldn't place my bets at this point. All we would say from our theoretical perspective is that there could be something to it. But we'd have to think twice about that. Yes?
If there's some kind of a trauma to the brain and the speech function is transferred to the other side, what happens to the functions that would normally be on that side? Is it just augmented, or do they get transferred to the other side?
Apparently they get transferred to someplace else. And there is such elbow room for taking on new functions in the human brain. Do you know that you can have 35% of your brain wiped out and not be able to tell it in your behavior at all? Now, it's got to be a very special 35%. Can't be just any 35%. There's a lot of the areas of the brain that are associational areas that are, in a sense, kind of free areas. And when those are wiped out, it doesn't seem to be any problem. In fact, even memory doesn't seem to be terribly impaired. However, if you wipe out, see this part right here, it's the motor cortex, and called the somasthetic cortex. That's the part of the brain that tells you that you're touching your arm, and it tells you that when you have contracted your arm that it is contracted, or tells you that it's extended. If you're clobbered there, or that is ablated, then you're paralyzed. If the speech goes, that's it. If this part, the hearing area goes, you're deaf. If the occipital lobe is wiped out, you'd be blind. So there are certain areas you can't do without, but all in here, you can even cut off the frontal lobes, you know. And you just give up your aspirations when your frontal lobes go. You become like a rather uninteresting vegetable once your frontal lobes are cut off, but other than that, you can carry on. I mean, a lot of people are like dull vegetables anyway, so you wouldn't even notice it if they lost their prefrontal lobes. Maybe they came with them already disconnected. Maybe that's the problem right from the beginning. Well, enough of biological underpinnings now. I want to get on to other parts of the theory. Let me just ask you if there are any questions up to this point. You might be interested in a little bit of on the studies of prenatal learning. It has been established that the baby in the womb does some learning. Now, whether or not you could pipe in some pre-math experiences and have this kid coming out calculating, it's probably beyond the realm of possibility. But, for instance, it's known that you can teach in the womb a baby to kick his leg on hearing a bell rung against the womb, against the mother's stomach, abdomen. We also know that the baby practices sucking usually his thumb in the womb. So that there are many, many x-rays of children sucking their thumbs. And those are the children who usually don't have to be too encouraged once their lips feel the nipple. They have all this practice. Some babies may be slow to start the sucking, and you have to really get the lips stimulated and so on. But those babies that have practiced in utero go right to it. So they already have learned the psychomotor operation of sucking and have rehearsed it in utero. There's a lot of movement as you know, in utero, moving of the limbs, moving of the head, kicking, and so on. So that a lot of psychomotor operations are going on there. How much goes on from a cognitive point of view is not known, and how much could go on if we set about it, I don't know. There are possibilities there. You know, the mother of Alexander the Great did all kinds of things over her abdomen when she was carrying the baby. She had the violin or the kithra or whatever it was played on her tummy, Greek instruments, and she knew that this child was going to be great. And so she started right in the womb, and of course there was nobody greater than Alexander the Great. He conquered all the civilized world. And the interesting thing was, his mother, being the wife of Philip of Macedonia, had a fairly powerful position and therefore could claim a number of resources, hired Aristotle to be his tutor. Now, when Alexander grew up, Aristotle made a deal with Alexander that when he went off to conquer the worlds, that he would ship back to Aristotle crates of things, bugs and animals and skulls and bones and rocks and examples of plants and so on, back to Aristotle from wherever he was. So that there was no living man on the face of the earth that had more information from the rest of the world than did Aristotle, largely because Alexander provided him with much of that. This was a real example of where the chief educator in the country and the chief ruler of the country got together and collaborated. Now, wouldn't it be nice if we could do that in our country, instead of having the chief administrator always being down on education? If we just could get an Alexander the Great who would love education and pour some resources into it, we could really do something. Well, that turned out to be a very happy combination. And of course, Aristotle's teacher was Plato. And Plato was exposed to Socrates. So those three guys, you know, they put together a body of thought that people are still drawing on. It is hard to think of anything in any fundamental sense that those boys didn't already think of in some way, shape, or form. That's why it irks me to have people read a lot of watered-down slop in school these days, when we could expose our young people to the greatest minds of all time. See, but no, instead Harper and Row or John Wiley or somebody else comes breezing in with their new brightly colored text, and you buy that stuff instead of reading and sampling the great minds. So one of the things Anisa is going to do over time is going to get the school system moved back onto the sampling of the great minds of all time, instead of just sifting through a lot of the garbage that we do sift through today. Well, there was one other point about prenatal learning. Oh, it wasn't prenatal, it's just perinatal, or talking about birth itself. One of the things our theory addresses is, of course, interaction with the environment is the thing that sustains the actualization of potentiality. And if you want potentiality to go on being actualized, you must introduce novelty into the environment, because you habituate to the same environment. That's why you see in an Anisa classroom, some things are taken off the shelf and put in the cupboard for a while, and then they're taken back out, and then they look new, and the child interaction with them, you take some of the old stuff and hide it. Or you bring absolutely new stuff in at the same time, you see. So the introduction of novelty is important. That addresses that balance between permanence and flux that Whitehead was talking about, preserving order amidst change and keeping change within order. Now what happens, and our theory would say, supposing there's too much flux. That is to say, the interaction with, that there are too many new interactions with too many new environments all at once. This is bound to be traumatic in one way, shape, or form. So you don't want too many new environments and too many wild new interactions at once. So what does this speak, what does this say then to the birth process itself, which must be really coming from one environment, warm, dark, wet, to one that's bright, noisy, and dry, and unconnected. You gotta do your own breathing. There's no connection with air itself inside the womb. That is such a traumatic break, and most psychiatrists and psychologists have claimed that the birth process is traumatic. Now there is a physician who's kind of stolen our thunder, just because we didn't get our thunder sounded soon enough, but nonetheless we don't mind, because he's worked it all out and it just fits in magnificently. His name is Frederick Lavoyer. He's just published a book called Birth Without Violence, which fits our scheme almost 100%. First of all, he says, for heaven's sakes, don't yank this baby out and turn him upside down and swing his little wet body in the breeze. I mean, that is a traumatic shift. Instead, he takes the baby, as soon as the baby comes out, he milks the umbilical cord, like I was saying before. The baby is kept very warm and is placed immediately on the mother's abdomen, so that the baby still feels the contact. At some point, the baby is then washed off, but in warm water, the same temperature as the amniotic fluid. You know what it is if you jump into a pool and get yourself wet, and you jump out and the wind blows. It is almost traumatically cold. Well, you can certainly understand what a baby's going to feel like if he's yanked out of this warm sack and is held upside down swinging in the breeze. I mean, that just must be downright traumatic. It's wonder they ever survive. And of course they holler and scream, and the physician smacks him on the bottom to get him crying. Well, Lavoyer doesn't do any of those things. The baby's kept warm. He's not introduced violently into this by swinging upside down and in the breeze. He's put in warm water. And he has photographs in this book which shows the baby's face when he's born in this way. And he has this self-satisfied grin on his face the whole time. I mean, it's quite a remarkable change. Because when you see most babies born, they look like they can hardly stand the change. Their faces are all wrinkled up, and the poor little things are crying their heads off. But his babies all have this look of great achievement on their faces, you know. Just kind of a, well, the photographs I saw, they really do look like they're smiling.
That was on TV.
Did you see it on TV?
I didn't. My mother saw it and she was telling me about it.
Oh yeah. Did you see it? Didn't they have like they have a little smile?
Just like a smile.
Yes,
Well, I only saw. I didn't even know it was on TV. Patami just gave me the book now.
He was on Today's Show.
Ah.
One time when I happened to be home and I saw it. It was marvelous.
Did he have videotapes, or they just showed the photographs of the babies?
No, videotape.
Oh, videotapes.
Yeah, it was really wonderful.
It turns on the lights.
Yes, that's right. It turns down the lights, because can you imagine being suddenly brought into this with bright light, and you've never had photons impinging upon the retina before? Well, you know what it's like if you come out of a dark room into just the bright sunlight. It's downright painful. So why not just turn the lights way down and let this child get used to moving from one world to the other?
The look on that baby's face, I will never forget it. It was just so beautiful.
Well, you see our own theoretical perspective pertaining to the introduction of novelty as it relates to the interaction with environments would exactly predict that we have to modify the way children are brought into the world. And so that's a kind of an interesting advancement. And I think this business of traumatic separation for 24 hours after birth from the mother is just bad news. Nowhere else in the whole realm of living creation is the newborn infant stolen away from the mother. And in a lot of hospitals, they don't even bring the baby to the mother for 24 hours. Well, you know, to be severed and disconnected from your source of life for 24 hours in alien surroundings with somebody putting something flannel on you, which must be equivalent to putting on a steel wool jacket next to your bare skin with spikes in it. By comparison of that softness, you know, the baby's covered with the waxy lanolin and it's in that warm water. Well, there's not much friction. Now you're going to have this flannel. Well, we think the flannel isn't very scratchy. But you've got to believe, by comparison, it's going to be pretty scratchy. Well, and then to be stuck in a room all by itself, well, we would put that baby right with the mother and leave it there. And you might want to put it aside for a little while, and if the mother needs some rest, but not very far. Now, I just read in the paper the other day that some Japanese company, Japanese are marvelous for finding a way of translating a little idea into a multi-million-dollar project in the most inexpensive way possible. They now have a little gadget that makes a sound the same as the mother's internal heartbeat as it would be perceived by a child in a sack of water, 9% salt solution. And you can now buy this little device and put it on near the baby's bed, and he stops crying right away. He literally goes back, enjoys a little bit of the womb again, in terms of that one feature. So you can buy this thing for $2.50. Probably cost him 13 cents to make it. And I tell you, I got to get a couple of Japanese on my staff to help me translate. If I could just find the right gimmick for some of these ideas, I'm sure there's a multi-million dollars around the corner if we could get to it. Okay, let us now turn our attention to the categories of psychological potentialities. The word psyche comes from the Greek word that means soul, or in more modern context, mind. So psychology means literally a study of the mind, and a psychological potentiality means a potentiality that pertains to the mind. Since the mind is the seat of learning, we say that psychological potentialities refer to new ways of using energy that come to you through learning. And we have identified 5 basic kinds of learning then. Psychomotor, perceptual, cognitive, affective, and volitional. Most schools concentrate on the kind of learning that is represented basically by thinking, or the kind of thinking that has to do with storing information in coded form, rote memory. In other words, most schooling centers around dispensing information that you want the child to assimilate, and then you test to see how well he's assimilated it. We are less interested in what he does with the information, and we think that's a grave mistake. Information is important to have, but for what reason? We think that question has to be asked all the time. Otherwise, there's no end of things you can require this child to memorize. All the county seats, all the capitals, the depth of the sea, temperatures at the North Pole. I mean, there's just no end of information in the encyclopedia you could require this poor little child to memorize. But so what? We are more interested in Anisa, in them having a fundamental fountain of information to work with in certain ways, which will make them competent individuals to deal with their life and their environments. And that concerns process as opposed to content. We'll be dealing with a theory of curriculum on Thursday. Thursday, Mag? Yes. Tomorrow? Yes, it's tomorrow. Well, since the theory of curriculum is so closely interrelated to the theory of potentiality, it's hard for me to separate them, quite actually. Well, I think most schools would say to you, and most educators, that knowing how to think is fairly important. But did you ever meet anybody who knew what thinking was? Exactly. Well, it seems unlikely that if you don't know what thinking is, that you'd be able to teach somebody how to do it. And if the professors in the universities don't know what it is, how can they teach the teachers to do it and then pass it on to children? Now, it's obvious children are thinking, but if you don't know exactly what it is, it's going to be very hard to teach a child how to think. Same is true for all of these. It's very important to know how to perceive things. It's very important to know how to... After all, when you learn to ride a bicycle, we say he learned how to ride the bicycle, but there was no information that he stored in the sense of necessarily in a cognitive sense, symbolically represented. And in fact, if you tried to teach a child how to ride a bicycle by giving him a course in bicycle riding 101 in which you never had the bicycle, I doubt if he'd learn how to do it. You'd say, well, you mount the bicycle, this is the seat, and you give a little test. Where is the seat? You have a little diagram, and you see if he can get it right. He could get all that stuff right, but he wouldn't be able to ride the bicycle. So what do? You give him an advanced course, bicycle riding 101A, 101B. Now, in which you tell him that you push the left foot down on the pedal, and that makes the right pedal come up, in which case you grab it with your right foot and push it down. And then you say, you will notice that the bicycle has a tendency to tip one side or the other. Now, when it tips to the left, quickly turn the bars this way, and when it tips to the right, turn it this way, and that way you'll keep the bicycle upright. Do you think all that information will do anything for the child? No, because bicycle riding is a psychomotor learning problem. Now, you might facilitate his learning how to ride a bicycle by giving him this information, but it's been found that it doesn't do very much. He has to sense, he has to have the experience of feeling how the bicycle is kept from tipping over when it leans this way and he turns the handlebars this way. So that how to move your muscles has to be learned. We said that learning was the key factor in the actualization of these psychological potentialities. The theory, therefore, has the burden of defining learning. We analyzed all of the major learning theories published to see if we couldn't find similar things in all of them, squeeze out a common denominator, and have for ourselves a definition of learning that would apply across the board to these 5 areas. And that's when we arrived at the idea that learning means differentiation, integration, and generalization. It means the capacity to differentiate experience by breaking it down into contrastable units, to organize those units in new ways, and to generalize those new ways to new situations. That's what learning means. Now, how does that apply to the psychomotor area? Well, it means you have to be able to break down the movement of the body into discrete elements by knowing which muscles are capable of what kind of movements. So you know that the arm can move this way, it can move this way, it can move this way, it can turn this way. And once you know all of those, and you can move them in their differentiated way easily, then you can put them together in a wide variety of ways, making patterns. When you learn to play the violin, you have to learn very complicated patterns. And practicing the violin means exercising those differentiated elements and getting them put together into a pattern. And once you know the C scale, you can generalize the pattern to the G scale. Once you know the G scale, it'll generalize to the D scale. See? If you don't know the generalization, then you won't transfer what you learned on the C scale to the G scale. One of the great lacks in American education generally is no insistence on, and therefore no opportunity for the child to generalize what he has learned. By providing him the occasion to experience a similar situation in which what he previously learned is now applicable under similar but slightly different situations, you see. That's why when you give a child a learning experience and it's very precise, and then you give him a test in which you are looking at the principles apart from or in a different situation, he usually gets it wrong. See? Because he hasn't been able to differentiate the elements, and the only way you know whether he's done that properly is if he can generalize. I'll give you an example of several of that in a moment. Now, supposing you could arrange some environments and guide the child's interaction with the environments in such a way that he could come to know about differentiation, integration, and generalization consciously. He would then be in charge of the process of actualizing his own potentiality. That is a key feature in the Anisa-Model, is to place the child in charge of actualizing his own potentiality. And the only way to do that is to enable him to learn how to learn. How to learn is in itself something that has to be learned, but it's never taught in schools directly. Our aim is to teach it directly. And when the child comes through the school system, he then is consciously able to direct his own learning. And therefore he becomes a master learner, a competent learner. That is, in my opinion, an enormous breakthrough in educational thought. We have interviewed large numbers of teachers who have heard of and have repeated the phrase, learning how to learn. I'm sure you've heard it yourself. But I can honestly say we never bumped into one single teacher who could tell us what it meant, even though they might have been using it for 3 years, 4 years, 10 years. Well, to learn how to know how to learn, or to learn how to learn, is to become consciously able to differentiate, integrate, and generalize experience as it comes in these forms. Tomorrow when we talk about the curriculum, you'll see these are broken down into sub-patterns and providing the child with an experience so that he can internalize that sub-pattern constitutes one very important element in the curriculum. Now,
Dan, And when you say consciously teach the child about differentiation, integration, and generalization, are you saying that when they are differentiating, you should use that terminology with the child?
Maybe not when he's 1 year old, because he won't understand it. But ultimately, yes. And already, I've heard the staff say when they're working with children, can you see the difference? Now, the minute you ask for a difference, you are labeling one part of this learning thing, which is differentiation. If you can't tell the difference between things that are different, you will not understand those things. And therefore no learning takes place. If you can't see how they are related, which is a form of integration, you will not understand how they are connected, which means you won't be in touch with them, and therefore you haven't learned them. And then your learning isn't very effective if you can't transfer that to another situation. Let me give you an example, which has to do with concept formation or classification. As a chair. Now, when you teach a child that something like this is a chair, say you give him an experience of an actual chair, that one right there, and you refer to that as a chair, he sits on it, he sees you sit on it, and he understands that that is a chair. How would he ever recognize that this is a chair? Because this is much smaller, it's one-dimensional, it's very different from that. Or, supposing we get that chair you're sitting on, which is made out of steel and plastic. Doesn't look like this one quite at all. How would he know that that is a chair? Well, he must be able to abstract, which means to differentiate, the features of that object that constitute chairness. It has a back, and he now must understand what backness is. It has legs. He must understand what legness is when it refers to chairs, because chair legs are different from cow legs and humans' legs. And he must see what the seat is. And this has 4, this is 1, and this is 1. Because if an object, which we call a chair, suddenly loses its back and has 3 legs, we call it something else, called a stool. Now, the only way the child can ever generalize from that experience accurately so that he can call that thing you're sitting on a chair too, which is quite different, it's made of different materials, has a different shape, is that he can identify that the one you're sitting on has a back, it has 4 legs, it has a seat. He cannot make the generalization if he didn't make the differentiation and got it integrated. Because, you see, if you have a back and you put the seat here and you sprinkle the legs out like this, the integration is wrong. And it no longer constitutes a chair. So, you've got to have the differentiations right, the integrations have to be right, and then when you can make the abstractions and you can see that the differentiated elements are there and integrated in the same way, he will see that this is a chair, that is a chair, and that is a chair. Yes?
Would you suggest using all of the terms with young children?
Ultimately, yes.
It's like seriation.
That's right.
which they can understand.
Because there is an advantage in knowing a name to the thing you're doing. What you going to say, Meg?
Oh, I was going to say that we would like the youngsters at some point in time to know that this is their reason for being in school, to become competent learners, and that they talk about it all the time and have a sense of what it's all about.
What we usually do is we say, what your seriation is, and then explain what seriation is
Yes.
over and over, because we have very young children.
Yes.
So, but they wonder about that. I think they enjoy learning
Sure.
larger words.
Now, you're going to have to use your judgment in this, and I wouldn't be upset if when you're using the word seriation, the kid doesn't get it right away. Chances are he will understand what you want him to do when you use the word seriate long before he would use the word seriation back to you, because it's a little complicated. But that's true of all language. Reception precedes production in all language. So that's all right. Children can understand very difficult words if they hear them often enough and they can distinguish them, differentiate them from other words that may be similar in some way. Well, our point is a very basic one, namely that if we are to design an educational system for the year 2000 and beyond, an educational system which is going to stand us in good stead for the next 500,000 years, say, it must focus on the creation of the most competent learners, because they will be the people who will be able to survive the rapidity of the change which we are going to be enduring. They will be the ones who will be able to mount the challenges which we are bound to face. The children who won't survive are going to be those who come through a school system based entirely on a content curriculum where teachers' role is conceived in terms of disseminating information. Because, my friends, that information will be out of date almost as soon as half of it is out of your mouth. The Library of Congress will double in size in the next 8 years. Advances in technology will make this, and we will be like manufacturers turning out defective products. Jerry Weinstein, who's a member of our faculty, made an interesting analogy about education to show how senseless it is. He said, we build a factory here that turns out kids, called a school, and it turns out that all the kids that we turn out aren't equipped to deal with life out there, and so it is decided that they're defective models, that something has been defective in the manufacturing of them. So they're sent back. So the first 500 come back, so you build another factory over here to repair the defective models. But you keep on turning them out defective. So you have to build a bigger one here now. You don't have to increase the size of this one, because you keep just turning out the same defective models. Pretty soon, you just have an enormous factory here that's doing nothing but repairing defective models that keep turning back. Now somebody, somewhere, at some point in our history, has got to reshape up the factory and turn them out right the first time. Now, in essence, that's what we think we've done. Now, we haven't had a chance to get our models out into the world yet. You know, the first crop won't be graduating for another, what, 10, 15 years. And that's an awful long time. And we need a chance to do it and do it right. We should be down here with you, working at your elbow, 6 hours a day for 3 years. And we should be working with children who were with us on a good diet the year prior to conception, whose mothers worked with their children for 2.5 to 3 years before they went into your preschool. Now you know very well, intuitively anyway, that if the mother embarks upon an educational program for her infant on day 1, and that child is put together and is in superior biological condition, that by the time that child reaches Suffield kindergarten, Harriet is going to have a herd of little theorists on her hands and will simply be hopping to keep those little minds engaged. And by the time they reach whatever level you're teaching, what level would that be? 5th. You see, you'll be having a run for your money, all of us will. I'm glad we got a few years before that's around so we can get our ducks in a row. Now, The experimentation I've done with my own children, which has been fairly limited, at least convinces me that there's no ends of possibilities once those first years are treated right. Just no doubt about it. And we are longing, I even went so far in Massachusetts to examine how we could set up cottages on the UMass campus and take the illegitimate babies that become wards of the state. Because it's now known that children who are born illegitimately and become wards of the state later fill up the detention homes and the prisons or the mental hospitals. And that the children of those people, when they grow up, also become wards of the state. There's a pattern set up. Who's going to intervene? Well, we would volunteer to intervene. And we would make our graduate students live in these houses for a year, looking after these babies. From day one on. They would do all the feeding, they would learn all the nutrition, they would do all the stimulation all day long. And you know very well that a baby that would come through that program is not going to be a ward of the state. They become the governors of the state. I mean, that's indecency. You'd be wrong, you'll see. Why not? But you know what? In Massachusetts, they don't have any homes for babies that are wards of the state. They are immediately assigned to foster homes. And in many cases, that's bad news. Really bad news. I don't know how they do it in Connecticut. How do they? Same way? In some places, they actually have state-run orphanages. In other countries, they do too. And that would be an ideal situation for us because the children have no parents to look after them. And we would have graduate students looking after them. And we would build it into their program. They would have an internship where they would live in those cottages and learn what it is to look after a baby right from scratch. They would be under supervision, of course, with expert people. Yes?
The only problem is how about mother-child relationship? If these graduates every year keep switching, wouldn't there be some problem there?
Well,
psychologically?
We would try to have a kind of a house mother who would move in and look at a cottage mother who would be there the whole time. But she would be assisted by the students. So that and I would be there every day. You see, I was a way of getting lots of babies, which I adore, without having to... Well, no, wait a minute. I wouldn't want to give up that part of it. Oh, you jump to conclusions, you people. It's my wife that doesn't want to go through through the 9 months. And when we heard Patabi's baby cry, you know, there's some... the Lord made the babies cry such that it cannot be ignored. And no matter how you'd like to pretend he's not crying, it's there, and you can't do anything else until you attend to it. And I realized when I heard Patabi's baby cry the other day that I'm too old to have the baby crying all the time. Now, I'm not too old to run an orphanage where somebody else listens to it cry, where I can leave and go home. But what's that? I can be the grandparent, that's right. Well, are there any other questions about the material we've covered so far? Do you get a sense of the coherence of the model as we talked about it the first day and the way everything is connecting and hanging together? Yes. And when you tomorrow see the curriculum theory and the theory of pedagogy and see how this impinges upon identity formation, I think you'll begin to see how the whole thing hangs together in very coherent fashion. Mag, do you have any...
Well, I'd like to give out the guide in the process of becoming theories of curriculum and teaching.
Good.
Some have it from last year, but, you know, if you want to give it back, I'll take it back.
Could I just mention something, please?
Yes.
After all of this learned theory, I want to say something very prosaic, but on Thursday...
Can you hold on, please?
On Thursday, not tomorrow, but Thursday for lunch, I'd like to have everybody come up to my house for hot dogs on the grill, and we'll try to do it very quickly because I know our lunch hour is very limited. But I'd be glad to have anybody come who'd like to. If you're on a real special diet and have to eat special food, bring it over.
Can I... on your behalf? We'll stop on Thursday then at 12, and we'll come back at 1:30, and that'll give us an hour and a half. And that would be very nice indeed. Anything else? All right, see you tomorrow morning. I have one child. You answer each of the questions listed under the theory of development on page 2. And by way of reviewing that, make an introduction to today's session, which is going to be on curriculum. I think you are all by now pretty well aware of the basic propositions in the theory of development, namely its definition, translation of potentiality into actuality, that process is sustained by interaction with the environment, that there are two basic classifications of potentiality, psychological and biological. Nutrition is the key factor in biological actualization, the actualization of biological potentialities, and learning is the key factor in the actualization of psychological potentialities, and that the psychological potentialities have been broken down into 5 categories, and that learning is defined as the ability to differentiate experience by breaking it down into contrastable units, integrating those elements in different ways, thereby yielding new wholes, and then generalizing those new wholes or those integrations to different situations. That's more or less the basic propositions of the theory of development. I'd like to add just a couple of additional things that we didn't go into yesterday. One has to do with the relationship between this theory of development and evolution in the universe. As you know, we've always been mindful of the requirements for developing a comprehensive system that would be characterized by adequacy and coherence and logical consistency. And we had those concerns because we knew that billions of dollars have been poured into and then integrating those cells. Now, the integration doesn't just mean being hooked together. It means being hooked together in such a way that all the parts are related functionally. The liver is connected. The liver isn't just in there doing its own thing. In fact, the minute an organ decides to do its organization, like a school, if some part of it decides to do its own thing, irrespective of what everybody else is doing, then pathology that comes into the system. Same way in a family, same way in any organism. As long as you're a part belonging to a whole, then how you are and what you do has to be conditioned by, influenced by, and compatible with. In essence, that's the meaning of integration, the relationship between parts and wholes. Mag was telling me in the car coming up, she's been dipping into a series of 4 volumes reporting the contributions of members attending a symposium, was it at MIT? Talking about fundamental concepts about the nature of being, and ultimately it's what it came down to. And one of these books is called Parts and Wholes. And it is a discussion of how things come to be organized and to make up an organismic whole. That issue is such a fundamental issue in philosophy that it was that concern that led a group of philosophers to break away from mechanistic notions to consider organismic notions. That's why Whitehead's philosophy or cosmology is called the philosophy of organism, and it is the philosophy of how many things become one. Because in essence, the translation of potentiality into actuality is a process of uniting and synthesizing many things into one thing. That's why when a child is exposed to highly discontinuous or traumatic experiences, the experience comes off as traumatic because the child was not able to relate everything. He was not able to differentiate the elements of that experience and get them integrated. Not only the elements that he's experiencing, but integrated with what he's been. That's why we prefer a more continuous kind of experience. Hence our concern for the delivery of a baby in a way that enables it to negotiate the rather incredible difference between life inside the womb and life outside the womb. The secret of progressive integration of more and more things is a certain kind of organization which, in a sense, characterizes what we mean when we say something is organismic, is that it is hierarchically organized. So we might then characterize development as an increase in the number of differentiated elements which become hierarchically organized in order to preserve the integrity of the organism over time. And that's precisely what has happened, so far as we can tell, in the course of evolution. This principle is a very important one for teaching, because every time you can put together an experience that facilitates the hierarchical organization of that experience, the more rapidly it can be assimilated by the child. if you don't do it for him, and I'm not suggesting that every single time you want to, but if you don't do it for him, he must do it for himself. And having to do it for himself is good. But if you don't know that's what's got to happen, and he doesn't know that that's what's got to happen, in order for the experience to be powerful in drawing out his potentialities, then it's left up to chance. And I'm afraid chances are he won't do it. Now, I'm speaking to you on a very abstract level, and momentarily I'll come down to some concrete examples so that you can experience it. Another way of saying this in terms of curriculum is that experience needs to be sequential. Some things are necessarily prior to other things. And if you get them out of order, you introduce discontinuities. And when discontinuities are excessive, the child's experience will be fragmented. And now he's left in a differentiated state. And if he can't manage it and you don't help him integrate all of that, then it will pass over him and not become a part of him. And you will have wasted your time and his. Now, usually when an experience passes over a child and leaves no trace, he is aware of that. And his interpretation of that is very apt to be in terms of failure. And he will be apt to make that interpretation of the experience because he is assisted in making that interpretation by the teacher. After all, if the teacher gives a child an experience and you don't see any change in him as a result of it, and then you examine him to see if there were any results and you find there were no results, then you gave him an F. So that in many cases, the letter grades we give children are assessments of teaching quality. That's why you should always be careful. In fact, I'm sure that's why some teachers just give all A's. They somehow intuitively realize that the grade is really an assessment of their teaching ability, and therefore it's kind of a self-grading situation. Well, that's only partially true, of course, because in some cases, teachers are making very good efforts, and for some reason, children are not benefiting from the experience. That's why we propose a differentiated staff, where there are some people whose main thrust professionally is to try to find out why children are not benefiting from the experiences being provided. And an analysis of that should yield some information which would be useful for the teacher in changing things in a way that would enable the child to benefit from the experience. Well, we're going to come back to this hierarchical notion of structure and organization a little bit later on. It arises out of that fundamental ontological principle that something always has to come out of something else, and that it gets built up slowly. Let me give you an example of discontinuity, which we were faced when we first came to Suffield, and Dick will remember this, probably Ed too. But when we first came down to talk about doing Anisa and saw the first draft of the proposal, it was to go with Anisa K through 12 in the first year. Or was it K through 7?
No, probably 12. We had an eye as an untouched.
I think it was K through 12. Well, Don Streets and I came down. We saw it said K through 12 in 1 year. Well, it just sort of floored us. And after we picked up our teeth and sort of got them back in and everything, and sat down, we had the job of, in a very gentle way, explaining why this was a violation of the organismic principle, and therefore wouldn't work. Now, in those days, we didn't have 2 years of discussion of the nature of organismic thinking, and therefore that passed over just, I don't know if Dick remembers that discussion or not, but see, we were trying to explain things to people who hadn't assimilated philosophical perspectives, so there wasn't much to connect with. And so it was that very difficult job, in a way, of trying to quickly build something there that you could connect with to build your case on. But I think from what you've heard thus far, you can see how impossible it would be for Anisa to go K through 12 in 1 year, especially knowing us like you do, and how few we are, and also the fact that we have not developed many of the materials for, say, junior high and high school. Just, there's be no way we could deliver on that. And in any case, you can see that an Anisa kid who started from the womb under the program, by the time he gets to junior high, is going to be quite a different creature from somebody that you start with in junior high right now who didn't have all of this.
Dan,
Yes.
let me bring that right home immediately, because the third grade teachers next year are going to receive an Anisa child that's had only 1 year of Anisa training. That was in the 2nd grade. That child that you receive next year will not be an Anisa child. You need to know that. You will not receive an Anisa child that's had a nursery K1-2 experience for at least 2 more years, which means you're going to be working with a partial, and that's true for 4th and 5th. Do you understand the way I'm doing that? I did this the other day on paper, and so you're not going to see all of the things that have happened, because, and we have lots of subjective impressions that the Anisa child is going to be different, and quite clearly, but you're not going to notice that difference next year. That was my point, and it's because we are sweeping it up gradually rather than putting it in.
And also, you may not even notice it when the Anisa child comes, because by that time you have worked for a year with somebody who's had partial exposure, and that means that your own development and working within the system will have changed a little bit, and it becomes progressive. You don't notice small changes. You only can notice big changes. I notice it, for instance, if I notice there's tremendous changes in my daughters if I'm away for a week and I come home. Especially 5 years ago, I'd hear all kinds of new words and new mannerisms and so on. Because if you're away from a week, so much goes by. But if you're there every day, it's hard to notice it. So there will be tremendous changes, and I wish there were some way of making an accurate documentation of precisely the nature and magnitude of all the changes we might experience. The other day we were talking about evaluation, and we won't have time to talk about evaluation in the Anisa theory of evaluation in detail. We will touch on it though when we talk about teaching, because part of the teaching function is evaluation, of course. But just to digress for a slight moment, we've always said that if you take any dimension of education, and you might say the regular system on a curve of achievement does this much, we would project that Anisa would do that much, which is just a little tiny bit better. And on this dimension, that an ordinary school might do that much, and an Anisa school would do that much. And on some dimensions, it might look like that, and on some it might look like this. And so you'd have a whole lot of them. But in each case, we would presume that the Anisa perspective would be more powerful because of its coherence and adequacy, and therefore kids would develop a little bit better. In some cases, you might have the regular school doing something better than Anisa does. You'd have to expect that. And in some cases, Anisa might do it very much better. But most of the cases, I would expect that Anisa does just a little tiny bit better. Now, what we would expect to find, and as a matter of fact, what we are finding, is that if you take a test on this one dimension and give it to Anisa kids here and non-Anisa kids here and compare them, you will find that there is a difference, but it will not be statistically significantly different. And therefore the statisticians will say you could not, on that basis, say that the Anisa system was superior. However, if you add up all of these statistically insignificant differences and you accumulate them over 15 years, our prediction is that you will have an enormous net difference between the kinds of human beings that are produced by this system and the kinds of human beings produced by any other system. Our problem is, of course, we need 15 years of time to demonstrate that, working with groups of people before conception. The idea is that if you build a system that is organized so that you take out the discontinuities and that you keep every child on the cutting edge of his development, then of course his children aren't waiting around for something. There's always something to be done right on the cutting edge of their development, and children aren't asked to do something that is beyond them, thereby setting them up for a failure, which then upsets the emotional organization of the child in relationship to formal learning, which then is so distracting to him that he misses half of the experiences now that come after it. Now, if you take out all those things, we ought to see a cumulative effect, such that by the time the child is 15, he is a mature social being with an intellectual equipment that makes him eligible for graduate study, as we now conceive it in the university, on that level. Not in the same way necessarily. I was telling you yesterday about how we would go about that differently.
And some people, raise the question with us, isn't this forcing something that's not natural? And I think you might want to speak to that in this kind of context.
Well, I think anybody who visits, say, an Anisa classroom doesn't see any forcing at all. We've taken very seriously a perspective generated by Robert White on motivation. He did an extensive re-examination of theories of motivation. These are theories designed to bring a perspective to bear on the issue of what makes people do things. Because it is well known that people who have high levels of trying get more done than people who have low levels of trying. In other words, if you're going to have somebody who's really achieving all over the place, you've got a kid who's trying a lot. In other words, he puts effort in to what he does continually. And nothing is more, perhaps, difficult than working with a child who won't try. See, if he won't try something and just sits there, nothing happens. And that should convince you that there's something inside the child that is determining what he becomes. Because no matter how hard you may try to get him to try, he may not. And he has some say, therefore, over what he's going to become. And if he won't try, then there's not going to be very much achievement. Well, most theories of motivation try to explain trying in terms of drive reduction. If you're thirsty, you will try to get some water, and that will motivate you to go get it. If you're hungry, you'll make some effort, which when you analyze it will look like going after food. There's sex, there's shelter, you need sleep, and so on. These are all, in a sense, biological drives, which we try to reduce because they make us uncomfortable. So many theories of motivation are based on the thesis of drive reduction as the main idea. Now, White said that he could not buy that for man, or even for animals for that matter, because if you take a human being and you let him rest so that he's got enough sleep, you give him a good breakfast, he's had sex, he's warm, and he's not thirsty, and he's got good air. Now, does he just sit there like a bump on a log, feeling happy and grinning? No. In fact, he finds that intolerable. He now hunts for some stimulation. So that these drive reduction theories are homeostatic theories. Homeo means same, and static means state. So homeostatic theory is one that says that the organism will run around doing things until it reaches the same state. A thermostat is a device that keeps the temperature the same. And a homeostat would be presumably something inside us that makes us come back to the same state all the time. And of course, we do have to remain, relatively speaking, with the same temperature. If our temperature goes too high or too low, we're in trouble. And if we don't get food, I mean, there is a point at which all of these things are true, but it's just not the whole story. And most of these drive reduction theorists try to say that everything else that we do in life piggybacks on one of these drives. And Freud perpetrated the idea that all of man's achievements are nothing but sublimated sex drives. See? And, I mean, in very specific terms. He gives concrete examples. He said people who sit and knit are really masturbating. That's how far Freud made it. So, I know you didn't realize that before, but you probably never knit in public again now. But unless there's some nasty, unless there should be some nasty Freudian in the audience who now has a bead on you yet. Well, you probably haven't had a chance to study all of Freud, but you would find it fascinatingly disgusting, or disgustingly fascinating, depending on your orientation. You can ask Mag for her evaluation of it one of these days. But Freud says that we would not be building skyscrapers. We would not be building bridges. We would not be writing symphonies if we were not frustrated sexually. Of course, when you read the biographies of all those musicians, you wonder how they could be frustrated sexually, given what they do when they're not composing. Yes, right. But anyway, Robert White creates an analysis that shows why that cannot be accepted as the main perspective. And he develops an idea of competence motivation. And he says that an overarching motivating force in the human organism is striving for competence, because competence will make him able to control the environment better, and his ability to control the environment better gives him more control over the things that guarantee his survival. There's one thing just to adapt to the environment. It's another thing to be able to change the environment and make it better for you. That's what we do. We've turned on the air conditioning. We bring the lights in here. We put screens up to keep the bugs out. We have spray to make the bugs die. Man has done extraordinary things to the environment, as you know. Some not so good. It now looks as if there's going to be some very bad and unfortunate retroactive effects on the way we've treated the environment. In other words, the capacity of the organism to have effects on the environment is something we inherently are built to try to accomplish. And that he calls effectance. He chooses this word because it is related to the idea of our capacity to have effects on the environment. Now, our thesis was, if you could enable a child to learn how to learn, this would put him in charge of the process of becoming progressively more effective. And you would therefore be riding the crest of a natural wave inherently built into him. So our thesis is that accepting this is the way man is made, if we can provide an experience that matches where that child is developmentally, he will always be motivated. That means you don't have to force the child to do anything. Coming back to Mag's question, are you forcing these children to become geniuses against their will, and they'll burn out by age 12? Well, I've never heard of anybody pursuing his destiny at an optimum rate in terms that we conceive it who would burn out. Because you are not, burning out means or implies excessive something or other. The preliminary testing we've done on this thesis yields an overwhelming confirmation. In my own kids, if they're fussing and fighting and there's conflict, as there are apt to be among siblings, the quickest way to stop it all is to introduce a learning experience that matches their developmental level. And cooperation begins and fighting stops. And all that energy that was going into the fighting would better be invested in learning to look. What happened, Ed? Don't know? I jammed.
It's that shirt there.
It's that shirt there. What happens if you don't put the child in a experiential context that matches his developmental level? Well, you are suppressing his potentialities. And the legitimate or the inevitable consequence of suppression of potential over time is pathology. Mental illness on the one hand, delinquency on the other. And I'm going to explain those dynamics a little bit later. And we will have the occasion on Monday afternoon to talk about value formation and the structuring of the human personality, the emergence of the self, in which those dynamics will be explained in some detail. But for now, let me put an answer to Mag's question in just a couple of sentences. There is no justification for thinking that the Anisa system forces a child to do anything. The closest we come to that, which is 1,000,000 miles away, is a loving encouragement to try things. But the better we become in assessing developmental levels of children, the more expert we become in organizing experience that matches that, and the minute you have that match, you have water and a duck. The two go together, and the kid goes right into it. I'm absolutely sold on this idea. I have seen it so many times. And I have seen people who are sensitive to that move into a situation with children and have them humming and buzzing with vitality, enjoyment, excitement about the process of becoming and all the wonderment that life holds. And that's what a school ought to be like. And if it is like that, everything else that is wrong disappears. The destruction of property just evaporates. I demonstrated this myself in working with hard-nosed delinquents over time. There is no need to tear the place down if you are feeling good about yourself, and the only way to feel good about yourself is to sense that you are in hot pursuit of a worthwhile destiny that belongs to you and that you can get in charge of. And if you're having experiences provided for you by people who love you that enable you to get in charge of that destiny, then you don't want to put your energy into anything else, because nothing else is so much pleasure, so much enjoyment, so much pleasure comes from nothing else as it does from this. I've just seen that so many times that it would be very hard for somebody to come up with a pile of evidence to the contrary, in my view. And I'll give you some more concrete examples about that later. For now, I just want to make sure that Mag's question is answered. You know that we had some difficulty in getting the contract for Hamden approved because there were some people on the Title III evaluation team who visited Anisa and wrote a negative report. There was just one basic negative report. And the negative report was that he felt we were suppressing these children because he didn't see any of them fighting, being impolite, kicking one another, or destroying property. And he felt that young boys, this is natural, inherent part of a young boy, particularly. He was a man who was writing it, you see. And he had this ridiculous notion of masculinity being associated with destruction and loud and reckless and hyperactive and, tearing the place down and kicking the teachers in the shins. And when he came in, he didn't see any of that. He said, well, there's something wrong here. Well, of course, this poor man had no overarching theoretical perspective about life development. He wouldn't know what a first principle was if it landed on him, I feel sure. And therefore, as somebody suggested, he's comparing the kids in that school with his own boys. And he wants to assume that his own boys are the model, and therefore he thinks these are deviating too significantly from that. Well, that may be too harsh. Everybody's got a right to his opinion. However, if your opinion is going to influence the lives of others, then that opinion has got to be a responsible opinion. And to make an opinion responsible is to provide a rationale for it that functions as a justification in experience or in theory for that position. To just say it is bad news. And the problem is, a statement like that can be very damaging because people who hear it are not thinkers. And therefore, they just take it. That's why in courts, both sides of the case know that if they can get something said that is an unjustifiable or unsupportable opinion, it nonetheless has an effect on the jury, even if the judge says it's out of order and strike it from the record. There is no way you could strike it from the record if the jury's once heard it. That wouldn't be such a problem if juries were made up of thinkers. But they often aren't. Well, now I want to connect all of this with the Anisa theory of curriculum. Well, let me see first if I covered all these questions. Number 2. And 3 we've talked about. Potentiality, incidentally, refers to the possibility of a form or a structure, which is evidenced by a patterned use of energy when it's actualized. I'm talking in the most abstract terms now, but that's why one of these chapters in this new book that Batavi gave me called Process and Divinity, which is a series of articles written by the pupils and colleagues of Charles Hartshorne, the greatest living organismic philosopher now, who was also a pupil of Whitehead's. He's at the University of Texas. One of those chapters in there is called The Theory of Forms. And he talks about Whitehead's notion of potentiality being, in essence, a theory of forms. You see, there are all kinds of new forms of chairs that exist potentially that we've never seen yet. And someday somebody will make a slightly different chair from the 20 million different kinds that we have, and it will be different from every other kind, and its difference will be in its form. Its function will be the same. In other words, people are going to sit on it, and so on. You see, and we have wide-ranging forms from bean bags to overstuffed couches to wooden chairs to whatever, you see. So when you say, what is a potentiality, you can say to yourself, its abstract form, a possible, or the possibility of an abstract form of some kind, and when it is actualized, the form is seen in a structured or patterned use of energy. Pattern. Let me give an example of that will help you remember it. The patterns are going to be almost infinite. The form or kind of energy will be thinking energy. It'll be psychomotor energy. It'll be perceptual energy. It'll be feeling or affective energy, or it'll be volitional energy. And we don't see any other kinds that there are. Now, of course, down in the biological substratum of all of this, little nerves are doing all kinds of things, and the liver is doing various kinds of things, and those are all forms of energy. But when they come out and we see them, they are in these forms, these kinds of energy. But these kinds don't just spill out like a waterfall. They also structure in form. And the process part of the Anisa curriculum tries to identify the basic ones on which we think would equip the child to become a competent learner. And on top of that, then everything else the child wants to do or become in life, then it's possible. The idea is a fairly simple one, namely that you are not free to become what you want to become if you can't learn. I remember counseling so many young people from disadvantaged backgrounds, most of them black students from the inner city sections of Indianapolis. And they would say, well, I'd like to be a physician, I think. But by the time they're a sophomore in high school and have dropped out and have been in trouble with the law and have come from a broken home, that decision is unfeasible unless there is a set of Anisa kinds of experiences that will enable them to build up the eminence, the background, on which to build a career in medicine. Because these students would say, well, I want to be a physician. And I'd say, well, then we better get you into some chemistry. They say, oh, I don't like chemistry. So, well, you have to take some zoology, you have to dissect frogs. They say, ooh, boy, I can't get up a frog. So, you see, there's an enormous lack of freedom to make a decision about your future if you are not a competent learner. And if the school system hasn't given you that, it hasn't given you what you need most to to be in charge of your own destiny, because you are not free to become what you want to become. Now, if you become a fully competent learner, the range of possibilities for you are practically limitless. You can say, well, I think I'll be an engineer, and because you've had the Anisa curriculum and are a competent learner, you won't have any hang-ups about math. So you can be an engineer if you want to. But you can't be an engineer if you've got a hang-up with math. You say, well, I'd like to be a writer. Well, you have to be an expert with the language. You've had to have a lot of experience in putting your thoughts into written form. And it just amazes me the number of young people who arrive at the university who can't even put one word after another and think they're going to become writers. Our idea then is that if all of the basics of the Anisa curriculum are there, and every child that goes through it and it becomes a part of him in the sense that his potentialities are actualized at an optimum rate, then he is able to make a decision about what he will become, and more often than not, that decision will be realistic because it is feasible for him to do what he says he wants to do, because he has the equipment, cognitively, affectively, perceptually, and volitionally, to negotiate everything, every decision, every obstacle, all the requirements for getting where he wants to go. What happens in the life of a young person who, number one, can't decide what he wants to be, and, or number two, decides he wants to be something that there's no hope of his becoming because he doesn't have the background, and there's no hope of getting it now? We have large numbers of young people like that. The inability to decide what you want to become is largely related to having no experience of a wide variety. Because the passive experience of sitting in a class just learning from books and filling out multiple choice questionnaires doesn't give you a sense of what it's like to put your life's investment into some of these professions. That's why our reorganization of what might be considered a junior high or high school curriculum is to get kids in the community actively involved in working in the affairs of our country on a variety of levels. Because with that experience, you come to have a sense of what you would like to do. You have a chance to let your interests connect with something. That's one of the problems that kids have. The other problem is, if they are not competent learners, they won't want to try anything new anyway. And therefore, they're hesitant to make any decision to become something that's going to require substantial new learning because they just feel inadequate. If you feel inadequate, you won't try very many new things. If you won't try very many new things, you're not going to become something different from what you are now. Not very different anyway. And certainly you're not going to become very different very fast. See? Well, number 4, we did. Number 5, did. 6, we know that the interaction with the environment sustains the actualization of potentiality. We've talked about the Anisa definition of learning competence. Don't forget the chief element there is the conscious ability to differentiate, integrate, and generalize. See, dogs are able to differentiate, integrate, and generalize. But the difference between them and a child with learning competence is that the dog doesn't know that he knows. A child can know that he knows, and therefore make deliberate choices about applying what he knows to achieve a given objective. 8, I think we've explored. Why does everyone's destiny depend on being a competent learner? Well, it's not so much that everyone's destiny depends on it. The question might be better phrased is why does learning competence, or why is learning competence necessary for a person to be in charge of his own destiny? I think we've explored that. Number 9, I want to take a minute or two with. According to the model, which is more important in shaping the destiny of an individual, heredity, or environment? This was a question that you kind of got out a little earlier, Debbie. And this has some relevance now because that question hasn't been handled very well by our society and by educators and by theorists, and consequently educational policy is always confused until that issue is resolved. The work of Arthur Jensen on IQ of children from different populations, particularly different racial populations, has added additional confusion to the issue. Jensen is a well-qualified statistician, but he is not a very good anthropologist, sociologist, or geneticist. His thesis is, you know, that the reason our programs in Head Start and so on for disadvantaged youngsters, the reason those programs didn't work is that we expected things to happen from those children that couldn't happen because of genetic limitations, is about what it boils down to. And he did a lot of sampling where he claimed that he had 2 samples, say one of whites and one of blacks, that had comparable experience in their backgrounds. Well, any anthropologist and sociologist knows there is no such thing as getting a group of blacks that will have a comparable experience of a group of whites. Because if you're black in this country, you get treated differently, even in the most genteel circumstances. So his premise is erroneous, and therefore all of his data are called into question. Well, that's just one example. But over and above that, let us look at the issue from an Anisa perspective. We say that the actualization, the translation of potentiality into actuality is sustained by interaction with the environment. Now, it's true that you are born with a certain blueprint that puts you together in a certain way, and the way you are put together in a certain way is going to have an influence on what you eventually become. We know that more intelligent parents tend to have more intelligent children, and that this is true even if those more intelligent parents did not raise their own children. In other words, intelligent parents whose IQ measures a certain amount, say high, if their children are taken from them at birth and raised by somebody else, and you take children away from parents who don't have very high IQs and get them raised by somebody else, there is still a genetic factor determining it. The question is, there is no way to find out exactly how much. So we can't do very much about a person's genotype. Now, you know, they're experimenting with radiation and so on. You can actually change the chromosomes, the genes on the chromosome. But the only way we change them now is mess them up and usually get deformed children coming out of that. See, it's going to be a long time, if ever, that we will be able to get a microscope big enough to look at the atoms that make up that gene and kind of see which one isn't looking too good and take it out and put another one in. I don't know if we'll ever get there. So we can't do very much about this. Now, when this genotype is expressed and we actually see the human being, you get what's called a phenotype. Now something happens between here and here. It's interaction with the environment. And that, by golly, we can have control over if we want to. Now, we have no evidence whatever that in the course of evolution, the experience of people has been such that through the processes of natural selection, some people have become less intelligent than others, especially associated with pigmentation of skin. There's no evidence for that at all. Do you all know about natural selection? Let me see if I can give you an example. I'll give you an example of the giraffe. You know, at one point the giraffe had a short neck. How did it get long? Well, the giraffe moved from an environment where he was eating grass and so on to a place where the grass wasn't all that good, but the trees were better. Now, you have a group of 20,000 giraffes, and almost all of them have short necks. But because of a genetic mutation, which we don't understand exactly, a giraffe is born with a slightly longer neck. And he can nibble from the trees because of his long neck. So, he gets fed better than the others. Now, that means he's going to be around longer. And that means he's going to mate more. He's the toughest one. He's going to have more females. He's going to have more offspring. And that mutated gene that determines longness of neck will be transmitted to a certain percentage of his offspring. So suddenly now, the terribly short-necked giraffes starve. They don't even get to reproduce much. The babies that come along that have the longer necks, of course, are the best as well. And there will be both male and female babies with long necks, because this won't be a sex-linked characteristic. And so the longer-necked ones will get the pick of the best long-necked females, who are in the best condition, and they'll get together, and then when they have babies, they've really got long necks. If they get a double dose of long-neckedness. And you see over 20 million years, interacting in that environment has selected out for survival those who have the characteristics that enable them to make it in a given environment. And therefore, you now have long necks on giraffes. Do you know that the horse at one time had 5 fingers and sort of hands? But when the glaciers moved down, the horse was very small, you know. And the horse moved down to places where the terrain was rocky and so on. You know, having a soft, tender paw isn't all that good on rocks. So what happened over time with genetic mutations? Well, those who had stubbier fingers found it better to run around on the rocks than those that had long, spindly ones. And eventually what happened is, the thumb turned under, and became the hock of the horse. These other 4 fingers came down, they got shorter and shorter and shorter until they were just all like one finger. And the nail got bigger and bigger and bigger until it became the hoof. Now if you x-ray a horse's hoof, you'll see a hand in there with the thumb curled up making the hock, and the 4 fingers coming down into the hoof. Now, those with hooves survived longer and reproduced more than those who didn't have hooves under the new environment. And therefore, over millions and millions of years, the horse emerged as we have it now. So, even the genotype in the phylogenetic history of a species gets changed by genetic mutation. And we do not understand what makes a gene mutate. It just seems to be by chance or by accident. Now, most genetic mutations are lethal. That's to say, they kill you. But fortunately, almost all genetic mutations are recessive. And don't forget, you got a set of genes from your mom and your dad. So supposing you get a lethal recessive gene, recessive means that it doesn't have any effect when compared with a dominant gene on the same dimension. So supposing you have a gene for blindness and a gene for sightedness, and they come together, the gene for sightedness will always be dominant, and so even though you carry a gene for blindness, you will see. Now, the only time you're going to get a blind child is if you marry somebody and the sperm or the egg, which carries the gene for blindness, is matched with an egg that carries the gene for blindness. Then the child will be blind. And they will have only genes for blindness. But they could marry somebody that's sighted, and they could have children who would see, but all children would carry the gene for blindness. The thing that increases the probability of blindness, therefore, is if you marry your mother, who has the same genetic structure as you do, or you marry your sister, or you marry your first cousin. The closer you marry to yourself, the more likely you are to pair recessive, defective genes. That's why there is an incest taboo. At least that's one reason why there's an incest taboo. We are created to feel repulsed at the idea of marrying our own mothers, or our own sisters or brothers. And the reason is that you have large numbers of deformed children being born because you increase the probability of carrying defective recessive genes. Now, the converse of that is true as well. The farther you marry away from yourself, the less likely you are to pair these recessive defective genes. And that's why if you marry somebody of another race, that's the best possibility. That's how you get hybrid vigor. And you see we have a funny note. I mean, the evolution of the human species has always depended on marrying people of other races. So interracial marriage is the rule of human evolution, not the exception, in spite of what people prefer to think about it. And that's because you get hybridization. All farmers know it. You know, no farmer would marry a Yorkshire pig with a Yorkshire pig. I don't know if even pigs are called Yorkshire. Is that a cow? Is that a pig? That's a pig. You marry a Yorkshire pig with a Hereford pig. Now I know Hereford is a pig, but I can't think of another kind of pig. What's another kind of pig?